This is January 2016, paper 2. This is question number 5. A foghorn, this apparently is a foghorn, makes a loud, low-pitched warning sound when a ship is moving in fog. What is the relationship between frequency and pitch? Well, you could say higher pitch is higher frequency. Of course, you can say the reverse of that as well, that the lower the pitch, the lower the frequency. Anything for just 1 mark. The foghorn emits sound waves with a frequency of 160 Hertz, and the speed of the wave is this. What is the speed? What is the equation linking wave speed, frequency, and wavelength? So I'd want to see speed, wave speed equals frequency times wavelength. They would have also accepted V equals F times lambda. Make sure you can draw that lambda appropriately though. Calculate the wavelength of these sounds. So wavelength is speed over frequency, which is 340 meters per second divided by 160 hertz. And then we would get 2.1 meters for 2 marks. A student investigates how the speed of sound in air varies with temperature. The results are drawn on the graph. First one is draw a straight line of best fit. I'm going to try my best with this, but I don't have a ruler. But that's not so bad. Should be a straight line, and remember that a line of best fit goes through as many points as possible. If you can't go through all of them, you try and keep the same number on both sides of the line. They would give you a range of values here. It was somewhere between there and there. Anywhere within that range would be fine, because you're going to use the graph to find the speed of the sound when the air temperature is 20 degrees. So you go up from here, and then where the line hits, you're going to track across, and I think it's about 344. Notice there's 2 marks here because you're going to use the graph. So you really have to show them that you are using that graph. So go up to your line of best fit and across, and then put the number in. Now, apparently here, they were going to read it off for you, line of best fit extended. Student's own value from the graph, plus or minus half a square. So there is a range of values here. You're going to have to see what you come up with. I've got 344, but it looks like anywhere between 343 and 345, somewhere around there. The air temperature decreases while the foghorn continues to emit sound waves with a frequency of 160. Explain how this decrease in temperature affects the wavelength of the sound waves. So, if the temperature goes down, the speed of sound decreases. The frequency remains constant, so the wavelength decreases. So we could put that into the equation, V equals F times lambda. If this goes down and this remains constant, this would have to go down as well. Okay, and that is question number 4.